Welcome. In this video I'll be showing you how to solve different reaction equations. Most of the methods used in this video were presented in the video on reaction equations, which can be found in the iCard in the top right corner of the screen. Now we'll look at some examples that will get more difficult as you advance. The first example we'll take a look at is N2 reacting with O2 to create NO, and we now have to balance the equation. We'll start by noting down the different atoms presented in the reaction equation in a chart, those being nitrogen and oxygen. We'll now note down how many of each atom we have. On the reactant side, we have 2 nitrogen and 2 oxygen atoms. On the product side, we have 1 of each. We'll now multiply the number of atoms on the reactant side with the number of atoms on the product side and vice versa. We can see that 2 times 1 and 1 times 2 both equal 2. Since we get the same result on each side, we can then insert the number which we multiplied with in place of the coefficient in front of the different chemicals. However, we don't really show the ones, so we'll remove those. And we can now see that the reaction is balanced. This reaction, as we can see, is quite more complicated than the one before. This reaction shows butane, commonly used as lighter gas, being burned with O2 to create CO2, carbon dioxide, and H2O, water. Now we'll once again be using a chart. However, this time we'll break up the atoms by molecules. This is not always necessary, but it makes it easier to follow what's going on. We'll start by noting down the amount of atoms in each molecule in the unbalanced reaction equation. Now we will first start by trying to balance the product side. This is because the reactant side has the most complicated molecule, being butane. When balancing for the hydrogen on the product side with respect to butane, we can see that we get 5H2O. We can reach this conclusion by knowing that butane provides 10 hydrogen and H2O has 2 hydrogen, and we can therefore say that for every butane we must have 5 water, since 10 divided by 2 is 5, and we can likewise conclude that we get 4 CO2 by using the same method. However, we can now see that we have to balance the oxygen atoms as they are unbalanced. And if we try this, we'll quickly notice it's kind of impossible. The reason for this is because we have on the reactant side an even number of oxygen atoms, and on the product side an odd number of oxygen atoms. We can see that this is due to H2O, and in order to increase the number of H2O to make it even, we will have to add more butane, and we'll start by adding 1 more butane. Now we'll once again balance the product side with respect to butane. After this we get 10 H2O and 8 CO2, and we did this by using the same method. We'll also update the chart by using the same method as before, just so we have everything updated. We now, like last time, will have to balance the reaction equation with oxygen, and in this case the easiest thing to do is just take the total amount of oxygen on the product side, which is 26, and then multiply 2 with the number needed to reach that. In this case it's 13, since 2 times 13 is 26, and we now have a balanced reaction equation. Our last example for today is the reaction of CuNO3 reacting to become CuO, copper oxide, NO2, and O2. Now, the two brackets you see around NO3 might be a little bit confusing. However, it just means that we have 2 NO3 groups. The chemical formula could also have been written as CuN2O6. The next step is to balance the reaction equation. Once again, we'll be starting by drawing a chart, and we'll be breaking up the atoms by molecules. We'll also insert how many of each atom we have in the unbalanced equation. We'll start by balancing the reaction in respect to the most complicated molecule, which is CuNO3. However, it might be a little confusing as where to start. I would recommend starting with the atoms we have the least of and then go in order. So, starting with copper, we have one CuO, which we as usual will not be showing. Next is nitrogen, where we have two NO2. And lastly is oxygen. And as we can see, we have 6 oxygen on the reaction side and unfortunately currently 7 on the product side. 1 from CuO, 4 from NO2, and 2 from O2. Here, the only thing we can really do to solve the reaction equation is increase the amount of CuNO3 by 1. So, now we have 2 CuNO3 2, and we'll once again balance the reaction equation with respect to CuNO3 2. So we now have 2 CuO and 4 NO2. Before looking at oxygen, we'll quickly update the chart and then look at what changes are needed. We already know that copper and nitrogen is balanced since we balanced the reaction with respect to CuNO3 2, and we therefore should only have to change O2. So we'll look at the amount of oxygen we have on each side. We can see that we now have a total of 12 oxygen atoms on the reactant side, and counting all the molecules on the product side, we now also have 12 oxygen atoms. And this means that the reaction equation is balanced. That's all for today. And as always, feel free to like and subscribe. Feedback, questions, or suggestions down in the comments below. And as always, have a nice day and good luck with your work.